We are bringing this one home. There's a couple of familiar faces that will join us on the stage in a moment, a couple of people we've been holding back for the blockbuster finale. And as promised, there'll be time to hear from all of you hardy true believers who are here for hour 7 of the Industrial Decarbonisation Summit. So I'm going to get them all up on stage with me so we can get straight into it. We have Andrew Richards from the Energy Users Association of Australia, Helen Wilson from the Department of Industry, the federal government. We're delighted to have you with you, Helen. Lisa Zembrot from our friends and partners on this event, Schneider Electric. You know him, you love him. Bill Lilly from Race for 2030. And last but definitely not least, the one and the only Amory. Please give all of our panellists a round of applause. So I've had a couple of chats with Andrew over the course of today. He tells me that he has been saving up his zingers. So I'm just going to say, I don't even have a question. Andrew, industrial decarbonisation, what do you reckon?
Can I start by saying thank you for the invitation? And this has really been a fantastic event, so congratulations. I mean, that's what you said. Did you tell him?
Yeah, of course. Yeah, right.
Look, it's interesting. We're really pleased to be here. This is the sort of conversation we've been hearing in the room today, the conversations that most large energy users are having, particularly those who are sort of facing into the safeguard mechanism that's sort of made it very real for them. And for once in my life, I'm not going to completely wing it. I've written down some notes because today has been really eye-opening, particularly with the gentleman to my far left. Your presentation was like mind-blowing. Mind-blowing in the sorts of things that we need to be doing and the stupidity of some people not to do them. So congratulations. We often get asked, what do your members think about X, Y, and Z? And we will say, well, it depends on who you're talking to and what day of the week you're talking to them, because our membership is incredibly diverse. So everything from people spending $500,000 a month to $1 million a day on energy. Most are energy intensive. About half of them have safeguard mechanism facilities. So, as I said, they're really facing into this. Things are moving at great pace, as we've talked about today, both in a technology and also from a policy perspective. And then from a global perspective, we see things just on hyperdrive, particularly with the IRA and other things in the US. All our members are committed to net zero. Most of them publicly, some aren't publicly making that commitment because, to be frank, they may be listed companies or they have shareholders, and they actually don't want to mislead the market in the sense that if they can't get to net zero, or they think that their pathway is unclear, then they don't want to make that announcement. But behind closed doors, they're very much working on a net zero strategy. And they also have very strong ESG targets. So the commitment to do this, the commitment to move is very much there. Their shareholders are telling them, their banks are telling them, their insurance companies are telling them, their staff are telling them, and their customers are telling them this is where they need to head. So there is no shortage of desire or to move down that path. They're all facing into phase 1, 2 and 3 scope emissions. Scope 2 emissions is getting a little bit easier with so much renewable energy coming into the system. This isn't an electricity discussion, but there's a whole range of other issues in the electricity market that causes, so I won't even touch on that. That's another night's lost sleep. Scope 1 emissions is obviously we're at the safeguard mechanism. Huge technological challenges there. Huge timing challenges as well. I mean, the blue scope we were talking before about, we'll move along in incremental steps and then we'll make a big investment and it just goes like that. Now, that's a timing issue, that's a technology issue, and that's a capital allocation issue. I mean, one of the things we need to understand about Australian heavy industry is that we're a pretty small market. So our industrial base is relatively small by global standards, it's very old, and is normally part of a global enterprise. So that global enterprise is looking at a whole range of investments across the world on how they decarbonise in this case. Unfortunately, because Australia is so small, our guys get put to the bottom of the pile. It's like, yeah, well, there's only a certain amount of capital allocation we can make every year or so forth. So we tend to sort of miss out on the big licks of capital that we need, which is really why it's important for governments and others to be sort of stepping into that space, if you like. And congratulations to the government for recognising that they need to create that space. And despite the billions and billions and billions of dollars, Helen, that's sort of out there, when you look at the scale of the challenge, that's a mere down payment on what we need to do to decarbonise our sector. So there's some of the unique challenges that we have in Australian business. So by all means, let's talk about what's going on internationally, but there's some serious barriers here in Australia that we need to deal with. And this isn't to say, oh, you know, it's all too hard, let's forget it. This is like, no, we need to understand what those barriers are and think differently how we can move forward. I'm nearly finished, Luke. So rather than just sort of sit here and say, these are all the things that are wrong, let's think about the barrier busters that we were talking about earlier today. I've come up with a few things, which is where I've written notes. Right? So,
Mark, you need to capture these notes. Maybe take a photo of Andrew's notebook here.
One of the first things we need to start to do is change the narrative about the future state of energy. I know governments like to say my policy will give you really cheap electricity or really cheap gas. I've got to say that's a brave move these days, because I can't see, and our members can't see, a viable pathway back to really low cost energy. But it's confusing when you hear governments say we're going to have really low cost energy, because why would you then want to deploy a new technology that's anything different from the one that you've already deployed?
And do you think that that's like in the public debate, people are getting confused between zero marginal cost energy and the delivered cost of energy?
There's a whole range of issues there, and that part of that narrative, we talk about we need to do this at least cost, but that doesn't mean it's going to be cheap.
Yeah.
It's just the least cost option of an expensive range of options to get us to net zero. We have to do it, but you can't spend $200 billion on the energy system and expect your bill's going to go down. That's some magic math that just doesn't work.
Well, I think I'm just looking at Anna's slide from this morning, and then she's got 440 billion by 2050.
So the number gets even bigger. I mean, Greg Combay talked about this at the press club a little while ago, saying that there's 200 to 300 billion in the energy sector alone. That probably doesn't even include the investment that we have to make to decarbonise. That's just this system. So there's big numbers there. So let's have that honest conversation about what the future state is. Because unless you've got a clear understanding of what the future state is, how can you make the appropriate investment?
Yep.
How can you plan for that? So let's have that. I'll quickly. There's clearly there's a knowledge or a habit issue here. We just keep doing the same stuff that we've done in the past because it worked in the past. We've got to continue to think we're in a different state. And that goes from some of my members. It goes to people maybe advising some of my members. You know, thinking about that. I would like to think, here's an idea I'll leave you with. I've got a few other ideas, but I'll leave you with this one. Like a company, think about Australia as a small company competing in a global market. Now, you can't compete with the big guys. You can't go punch for punch with the big guys. So what are your natural advantages? What are the things that you can do as a small company to compete in a big market? And maybe our small size can be seen as a benefit. If we can set ourselves up as an industrial decarbonisation testbed and say to people, don't make mistakes in Europe, don't make mistakes in the US market, make them here. No, seriously, because that's the only way you're going to start to get the big companies to have the right sort of capital injection into a small country like this. It also brings the new technology in, et cetera, et cetera. Now, there will be some mistakes when you have to accept that, but it gets things moving. It elevates us as a company, if thinking of Australia as a company, up to the top of the list. That's just one idea. We just need to think differently about how we can compete, how can we attract capital, how can we attract technology. So I'll leave you with that.
And there's a big opportunity there in terms of what one can then sort of export back to the world in terms of know-how, right?
Well, even if it's just about our decarbonisation journey. I mean, if you look at safeguard mechanism, and we say to our members, you know, there's half our membership's sort of at that 100,000 tonnes per annum Scope 1 emission profile. There's another tranche underneath that that's sort of between 75 and 100. And we say to them, you may not be part of Safeguard now, but start paying attention, because at some point in the future, you'll start moving down the tranches.
Yep. Helen, thanks for being with us. There's a power of work going on within the federal government right now. We heard from Claire this morning around a lot of that. Tennant did his demolition derby of past and future policy.
Did she use the term demolition derby?
That was it. That was me. I'm sorry.
Okay. Sounds very unlike a bureaucrat to me.
No. I was just freelancing, and it was actually Tennant's demolition derby, not Claire's demolition derby. So I should
definitely more
not.
Tennant.
Indeed.
Captain CBAM.
Captain CBAM. That's right. But the point is, there's a whole lot of stuff going on. We're all, I think, in government and outside of government, hoping it all coheres. What are the things that you're seeing, reflecting on some of the topics we've been talking today, that are going to be really critical vehicles for carrying this conversation forward?
Okay, and Andrew, I'll get to test beds when I talk about artificial intelligence. You've got some good ideas. What I'm seeing global supply chains being reconfigured. I'm seeing strategic competition intensifying. As Andrew said, with the US IRA, many nations are reinvesting in their sovereign manufacturing capability at the moment, and recognising that the game has changed and the role of government needs to evolve. The Prime Minister recently said the government needs to be more strategic, more sophisticated and a more constructive contributor. Government will not be an observer or a spectator. It will be a participant, a partner, an investor and an enabler. And the Prime Minister also announced in that same speech the government will create the Future Made in Australia Act, with the aim of bringing together in a comprehensive and coordinated way a whole package of new and existing initiatives. I've been a bureaucrat for over 20 years, and the thing that I hear the most is that we need clear and consistent policy direction and market signals. So, Future Made in Australia Act, more detail will be released tonight. Luke knows if anyone asks me about what is in the budget, I'm going to tell you to turn on the television at 7:30 p.m. tonight.
So Danny Alexander, I don't know where she is, but she's got this theory that we should actually do a viewing party on the big screen for the budget tonight.
Oh, we should.
Totally right.
Don't do it on the roof, we'd all jump off.
No, you wouldn't.
Bloody hell, Luke.
You're not going to jump off. Come on, you're a policy wonk at heart, and trust me, while there's a lot that actually has already been announced, look, there's going to be more detail tonight, and you know what's been announced. Like, the government has announced investments in hydrogen, the Solar Sunshot program, an investment in quantum computing and funding for Geoscience Australia. But I also wanted to just touch on some of the work that the department that I represent, the Department of Industry, Science and Resources, is doing. The government's currently developing 6 decarbonisation plans, sectoral plans. We're doing 3 of them, one for the industrial sector, one for the resources and one for the built environment. And for the industrial sector plan, yep, lots of engagement done to date, but there is a lot more to come. So we're going to be coming out and talking to all of you. There's some areas of potential focus, and some of these topics I think have already been covered today. So that was really great to see. You know, access to affordable, low emissions hydrogen, adoption of circular economy principles, improving energy efficiency, and thinking about that, you know, green premium and the commercial gap to overcome. But one area that I'm responsible for is artificial intelligence. Now, we can make it artificial or we can make it intelligent. And the role of government is to encourage the adoption of existing technologies like AI that are going to play a role in decarbonisation. Recent research by McKinsey and Company suggests that AI applications in manufacturing alone could reduce energy consumption by up to 20% and decrease greenhouse gas emissions by 15%. Increasingly common applications of artificial intelligence in manufacturing alone include decarbonising the process of production, maintenance and supply chains, supporting circular economy design principles by optimising resource use, minimising waste generation and facilitating materials reuse. And lovely Chris from BlueScope, a bit of a plug for you, because you are using machine learning to analyse data streams generated during your steel refining process. You're combining information with historical performance, algorithms assist your engineers to determine optimal time to execute tapping, apparently, of basic oxygen steelmaking. But we won't get the adoption of artificial intelligence that we need unless we get the trust of the community. Surveys of the community have consistently highlighted they're concerned about the risk posed by AI. So government really thinking about how to boost adoption, how to get the trust of the community, because the community wants stronger protections in place to help manage those risks. So how can we boost adoption? By putting in place some mandatory guardrails or consulting on what mandatory guardrails would look like for the use of artificial intelligence in high-risk settings. So the government totally understands that AI, new technologies, have a really big role to play but we won't get the adoption until we get more trust of the community, and by thinking about some of the serious harms that could occur from the use of AI in what we call high-risk settings. So the government's doing quite a lot of work on that. And then we've got a whole range of other programs that can assist right from the very start of the innovation chain all the way up to the wonderful National Reconstruction Fund. I'm happy to talk about those when we get to the questions. But the one that I really wanted to call out is the R&D tax incentive. Hopefully you're all familiar with it. Don't forget, it's accessed by more than 12,000 companies each year and is worth more than $3 billion. I think we've got a lot more to learn from how we can make the R&D tax incentive a little bit more efficient, effective, and I'm happy to talk about that. But why don't I leave it there?
Sure. Thank you, Helen. I think that's a good roundup of some of the things that are on the agenda, and it complements Claire's comments this morning. Lisa, I guess, you obviously do amazing work at Schneider Electric. You're on the board of the EC, though, so you've got this broader industry view. I'm interested in some of the conversations we picked up in Bill's session, which was around how we grow kind of the ecosystem in this space. But I know you've also been listening furiously and taking notes throughout the day, so I'm happy for you to take it where you will.
Yeah, sure. Thanks, Luke. I very much enjoyed Amory's presentation and everyone else's this morning as well, and throughout the afternoon, because it's actually hard to believe what time it is now. That's how much fun I've had.
Good.
One of the things that really struck me, that I was reminded of multiple times through the day, is that the technology already exists. And so when we think about, how are we going to gain that momentum, it's very much about making sure that other people outside this room know that the technology already exists. And that's really critical because not everyone thinks that way. A lot of people think that the technology doesn't exist or that it's too expensive. And yes, it is a conversation about, is it CapEx, is it OpEx, cheap variable costs of renewable energy, nearly zero if the wind is free and the sun is free. But the investment required to get there, people see sometimes as a barrier. And yes, government can support the funding, but there also needs to be a very clear case for the outcome of that investment, or a clear understanding of the value that will be created as a result of applying the technology that already exists. So it's not cheap, but it's cheaper than the alternative, right? So the cost of not abating climate change, the cost of not mitigating climate change or not adapting either is so immense that it more than overshadows any cost that we could think of or even comprehend when it comes to the investment that's small by comparison that needs to be made. So the technology already exists. That was one of the things that really struck me. The other that really struck me is just how much waste we have. So at Schneider, we like to quote 60% of all energy is wasted, and we saw that multiple times in the presentations through waste heat and other types of waste. And it's really critical for us to understand what are the things that we can do to be more efficient, more productive, to eliminate that waste, or at least reduce it to an amount that is far more acceptable.
Which is so important in the context of fuel switching, right? And when
Absolutely.
you're rebuilding the system. So like the things that are happening on a site level sort of ladder up to that energy spend you're talking about, Andrew. So like there's a conversation here about the role that industrial businesses have in managing their energy use as a vehicle for managing the cost that they're ultimately going to be on the hook for of the system overall, right? Like these two things are not sort of siloed conversations, they're the same conversation.
You absolutely need a strategy. And this is probably one of the things that we haven't talked a great deal about today is companies and governments need a very clear strategy to decarbonize. You can't just go at it all willy-nilly and go do something at one plant and think that that's going to work for all the other plants. There really needs to be a very clear strategy to decarbonization. So that's the other thing that I would really point out. Digitization being the last one that I thought I'd bring up. It is absolutely critical, not just from an AI perspective, but even from the data collection so that we can understand where are we, where will we go. Jared actually mentioned this earlier, that comes to mind. So digitizing not just the data, but the processes is also really critically important. as we look forward. And I'll maybe pause there and jump in later.
Yeah. And one of the things that someone said over the course of the day was the digitalisation, the data, but then also kind of the culture of then using it and using it to drive decisions is the other bit that we need to be thinking
Making
about.
it meaningful.
Indeed.
Yep.
And governing it. Governing how you use the data.
Well,
Very
the
important.
data rights, is that what you're pointing to?
No, just making sure, I think we're all saying the same thing, that you understand what your data sets are, any kind of biases in your data set, and that you're governing the use of your data.
Okay. That seems like a perfect segue to you, Bill, in terms of the digitalisation question, if that's where you want to take it.
No, that's fine. I'm happy to talk to that. I think it's an excellent thing, and it's work that obviously we're supporting quite a lot within RACE. We're supporting data capture itself, some of those governance models that were just alluded to there. Understanding better aspects of what data and why. I mean, there's a thing called dark data, which is really down to data that's really not used, captured but not used, and or is out of date, for instance. So, that's an important portion of this. Looking at the emergence of different versions of learning. So, currently we do a lot of machine learning, which is really around processes today and making them more efficient. Moving towards, as we've seen in the last year, everyone's had a stab at ChatGPT or Llama or some version of that. But, the beauty of a platform like that is really putting in a natural language so that you're able to communicate with it. So we're supporting research which is actually linking that version of interaction with AI, with the broader standard machine learning optimization modeling. Cutting edge science that's looking really to help businesses be able to understand what's happening within their premises and make better decisions with it. So really looking at deep understanding of that. At a broader systems point of view, we're trying to really set the agenda to do this large-scale systems analysis across multiple different aspects. Digitalisation being one, sort of energy vectors in their various forms being another, economics layer being another, and the societal layer, which is really important. And then really trying to understand, our researchers that are here, understanding what people want and their expectations and building that within the system. So not actually dictating this to them, but having this happen with them. This is the most important aspect of that. And that's a cutting edge bit of science, how to merge that into these sort of standard techno-economic frameworks that we use for making value judgments. There's a lot to be done there, and there's a lot that we want to support with RACE, and we want to work with our industry partners to make that happen.
Amory.
Reflecting on what I've heard today, I'm seeing a bit of a gap because we didn't talk enough yet about what happens on the factory floor and the culture that yields savings. We give lip service to measurement, but I dare say most of the factories represented here might not be properly specifying and maintaining their sensors to give the accuracy and precision that are worth having. Or they may not present the data graphically in a way that can actually inform operational decisions. Mr. Lee, I mentioned in Singapore, does approximately 10-dimensional graphs because you can use not only 3D rendering, but also size and color and behavior like blinking and so on. So you can actually, you can't hold a 200 variable state space in your head, but you can actually see how it behaves and realize that you're really optimizing for a local optimum when there's a much bigger global optimum down here that you never explored. And the graphics can help you see that. It's important to create a culture of curiosity. Some places give a little recognition every week or every month for the person that measured and learned the most interesting thing that we didn't know about how our process was working. Some give a Goof of the Month prize to reward the most instructive mistake anybody made. Because people don't like to talk about mistakes, but of course that's the really informative part. And if you make it okay to talk about mistakes, you learn a lot faster. We often get hung up in the minutiae of incremental improvement without thinking through whether there's a fundamentally better way to do the thing we're trying to do, or maybe do something else that would be even better. I'll give a couple of quick examples. One of my favorite mining conceptual design projects was an iron mine in West Africa, that had a perched ore body with a bunch of perched water around it that was quite awkward. And you really had to dewater the mine to do anything, but the water would be very valuable down to the port below. So we just ran the water down and got some hydropower from it along the way, and got the ore down to the port in a kind of reverse ski lift with buckets on it. So we got about 96, I think, % of the gravitational energy back, and those two turned out to be enough to run an efficient mine without needing a power plant. Or there was a rather interesting place I went to once in the Canadian high Arctic, mining industrial diamonds, billions of dollars of diamonds there, polar bears and other interesting things. And it was easy to spot things that could have been done a lot better, like they had boilers to heat the living facilities, but they were throwing away the manifold heat from the diesels. But the more I looked at the whole operation, the more there was something nagging at me I couldn't quite figure out. So I asked, could I see the grade tonnage distribution of your diamond deposit? And they said, funny, we were just looking at that yesterday. There's this big gap in it. There's $1 billion worth of diamonds that should be there, but it's discontinuous. We can't figure out where it is. I said, how do you assay the diamonds? They said, caustic fusion. What's that? Oh, that means we just dissolve it in hot caustic soda, and that dissolves the kimberlite, and we're left with the diamonds, and we weigh them. So I got to thinking about that, and you know the movie Dune, where there are these sandworms? Well, it occurred to me you could actually make a sandworm that could munch its way down with hot caustic in its gut through the kimberlite pipe, kind of a carrot-shaped thing, rather small, would fit in this room more or less. And it would poop out diamonds, and you'd come along behind and neutralize with a bit of sulfuric acid or whatever. But that means if there were any sort of goose egg-sized ones, you wouldn't have broken them up with blasting first, and you'd get full recovery of the resource. So I tried this in our concluding dinner with the executives when they were rather well lubricated and a bit imaginative. And the CEO said, you know, that's such a good idea. It doesn't need a mine or a mill. It's a different way of getting at our resource with better recovery and none of the hassle. And I'd be willing to abandon our only 1/3 used mining setup here and switch over to your methods. And yes, hot caustic is nasty. You'd have to make the gut of the sandworm out of something fancy, but even if it's pure unobtainium, we'd make a great deal more money that way than with what we're doing now, except he was hired away a few months later before he got to do it, and no one else had the guts to pursue it. But it was still an instructive example of thinking through a completely different way of doing the job. And I want to end with one other sort of cultural example, or two, quickly. The Southwire is the biggest independent U.S. maker of rod wire and cable. There was a very tough time for the industry when Jim Clarkson and one colleague started systematically applying management attention to saving energy, and they managed to cut the energy intensity per kilo of product in half in a few years. by paying attention at every level. And that may have saved 4,000 jobs at 10 plants in 6 states, because the margin earned by the energy savings was just enough to keep them going through that difficult time. And my last example is from Ken Nelson's work at Dow's Louisiana division. Dow has very sharp pencils. They're really good at what they do. And they're exceptionally good at enculturating a lot of efficiency, but mainly in using heat. It turned out, when I asked a few years ago, they were not doing any of the fluid handling improvements that I mentioned earlier today, but they have a great many pumps and fans. But they're really good at heat, and Ken Nelson got going an interesting culture where people on the shop floor would suggest ways to save energy and reduce waste. So he ran a little competition to see what people could come up with. And the first year, it was something like I think 137% return on investment. And he said, well, that's odd. If there are all these $100 banknotes lying on the floor, somebody would have picked them up already, but we seem to have found a bunch. I wonder if there are any more. So they kept going. And the next year, it was an even higher return, and the next year even higher. And by the time they got through 900 projects, which took something like 12 years, the average rate of return was 202% calculated in advance and 204% confirmed on subsequent audit of most of them. And the returns were still going up. In other words, the moral of this story is that efficiency is not a depletable, rare resource. When you get good at it, you keep coming up with new savings faster than you use up the old ones.
It's a muscle that you build.
Yeah, exactly. Right. So I would really encourage you all to pay attention to these cultural aspects of how to capture a potential that we can't even imagine yet because we haven't done it yet. And then when we look back on it, we'll wonder, why did it take us so long? So this is what, in conclusion, makes me puzzled by an odd number I heard today about the $9 trillion cost of the energy transition. The first obvious problem with it is I don't think it's net, I think it's gross, and they forgot to subtract the cost of the business as usual scenario. That's the McKinsey error, since they should have known better before they published it in another place. But even more puzzling is, why should it cost more at all? Maybe there's a sign error here, because efficiency is cheaper than fuel. Renewables are cheaper than fuel. If you do efficiency and renewables instead of fuel, it should be doubly cheap, not doubly expensive. There's something odd in the math here. And, you know, arithmetic is not an opinion, but we really need to figure out, why are we talking about the extra cost of the energy transition when it's probably an extra saving? And it's interesting that the Oxford INET study came out in Joule journal a year or two ago from Rupert May's crew with Doane Farmer. They found that actually the faster the energy transition goes, the cheaper it gets. And it is cheaper than business as usual, assuming no efficiency and no demand response, using empirical photovoltaic prices and learning curves, but generating the photovoltaic price endogenously in the model, so the learning curve that happens in the market can also work in the model. Otherwise, you way overestimate solar costs. And the reason it gets cheaper as you go faster is you're capturing the savings sooner. So even without efficiency, this is not a question of what discount rate you choose. A rapid transition to 100% renewables, reliably integrated, turns out to be cheaper than business as usual at any reasonable discount rate. So the whole notion of there being cost to the energy transition turns out to be a sign error, and I'd be rather surprised if this didn't turn out to be true in Australia.
Indeed. The point about learning rates is absolutely critical in terms of those emerging technologies, and those technologies now well established, and solar is a incredible case study of just blowing all projections in terms of cost out of the water because of deployment and because of those efficiencies as the solar industry ramped up, particularly in China. But the learning rates piece also goes to the application of an integrated technology set into businesses as well, and the learning rates that sort of emerge from actually just doing it. And that's where we've had two sessions today, one which was focusing on the ecosystem, the other was focusing on decision making within businesses. Spoiler alert, they're actually the same thing. Like, as you do stuff within businesses, the ecosystem is allowed to develop and you get that acceleration, and that makes it easier for every single subsequent business to do the thing. There's been a lot of talk about subsidies from government, and another spoiler alert, government is unlikely to be able to pay for every single electrification or energy efficiency or fuel switching project in the country. But there is a strong case for government to support the businesses that are sticking their chin out for the first few, because there's all these spillover effects, right? And they are sort of taking the hit in terms of learning how to do this stuff, and the ones that go, 10th or 15th or 20th are going to have a much easier time of it than the ones that goes 3rd or 4th or 5th. So I think, but it all goes to that point around just getting started and having ambition, so that we can build that. I guess it's that word again, right? It's momentum.
I just wanted to build a little bit on some of what Amory's talking to, and some experience of looking at PV adoption in Saudi, for instance, when we were in the Middle East region in its entirety. And I was talking to a CEO of the company at the time of how they were setting world-best prices, and a lot of it, as he said at the time, was not rocket science. It was actually that they were designing better at the front end.
Yep.
They were actually taking the time to do the design, get it right, and be able to price appropriately, not then have to try and do it once they'd set a PPA price and then sort of have to come back and de-risk it, if you will. So they were actually just taking time to design properly, to be curious, essentially, is what Amory was talking about, at the front end of how do we do this well. And they were, being accused of being subsidised, etc. So, building on that, but it was actually really down to designing properly and building that, on that endogenous function. I mean, there are models where we build endogenous functions within learning rates, and sometimes they actually go a little bit too far out. But we do, and we have seen in these spaces that move quickly, just an ability to miss the signal completely. You look at this and it's just always out, and you're missing the boat all the time. And so when we start trying to make decisions, we need to keep that reflective. We need that to be part of the dialogue of decisions. I've seen lots of decision making where people just had an old number stuck in their head, just hadn't kept up. So there's also that, just being able to constantly communicate in this rapid change how things are evolving. Otherwise, you just get stuck in a paradigm of, what prices were even a year ago, but certainly, I've seen a lot of people with 5 year ago values.
I promised that I would give you all the opportunity to reflect on today. That's a good time for that. This is also an opportunity to ask questions of our panel. I'm happy to use this time in whatever way you see fit. There are roaming mics around and about. As I said earlier, if there is a point or a perspective or an idea that you think it's really important to ventilate in this room, now's a good time to do that. But also, we've got an incredible panel here, so if you have a question or something you'd like them to reflect on, we'd really welcome that as well.
Can I just potentially raise a future potential boom, if you like, for Australian manufacturing, particularly in steel? We talk about green steel or green materials. The greenest materials are the ones that we've recycled.
Yep.
And if you think about the massive growth we're going to have in renewables, and the NEM will be 6 times larger than it is today by 2050. So it's about 300 gigawatts. Based on a replacement rate of renewables of about 25 years, we're going to have to be replacing about 10 gigawatts of renewable energy by 2050 and about 5 gigawatts in 2035, and building up from that. So that's a huge opportunity. to basically ensure that we have the circular economy system set up so that we recycle all of that back into the energy system.
Yep.
We're not, and I understand why it's important that we build out, but we're going to continue to build out and then build and then build and then build some more. So there's a huge amount of waste potential there, but there's also a huge amount of recycling circular economy benefit there, where we basically can have, it's be like Grandpa's axe. It's the same axe. It's got 3 different handles and 2 different heads. It's still the same axe.
Yep.
It'll be Grandpa's wind turbine, right? So we've got to get much better at this. We've got to lean into this now because it takes a long time to set up those systems and change the culture. I mean, I was in the wind industry as a boy in the 2000s, and we just assumed that we just pull that down and scrap it. We didn't really think what was going to happen with it. You leave the concrete in the ground, you leave all the copper in the ground, all of that. And you think about a wind turbine, it's just steel, aluminium and copper and the blades, whatever they make them out of these days. We never really thought about how you actually, what's end of life and giving it a new life, and we need to get much better at that.
Well, where do you suppose is the world's biggest copper deposit, high-grade copper deposit?
It's in South Australia, isn't it?
Well, yeah, I mean, you
Chile.
could pick,
Chile.
Could have been one of the two.
Papua New Guinea, Zambia, whatever. But it turns out it's actually under Manhattan. It's all the power and signal wiring that was done under the old business model.
That's a trick question.
Where the miner sells tons of copper to a company like Southwire, which makes the wire and cable, which sells it to Con Ed, which puts it in the ground irretrievably, more or less. It's hard to get back. Now, suppose instead the business model had been to lease the conductance service of the copper. So the company leasing that service would have every reason to do R&D on wireless and optical fiber and so on to free up and recover the copper as quickly as possible to lease its services to somebody else. I think that's where the extractive industries ought to be heading. They lease the service rather than selling the tons, because in a world that's using fewer tons more productively, you really don't want to be in the tons business. So that revolution has yet to really take hold in Australia, but this would be a wonderful place to do it.
Yeah, I agree. It's and because we want to get to the space and where at the moment it seems like everything's going to get a subsidy, and that's clearly not sustainable
Does
going
it?
forward. I'll talk to you later. We've got to get beyond that, whether it's renewable energy or whether it's decarb. We've actually got to get to a point in the market where it's just steady state. And the sorts of things that Amory's talking about, where's the right incentive? It doesn't have to be it can be a policy or it can be a new market design. It doesn't actually need to be just more subsidy or more cash. So one of the things we need to be leaning into more, and this is an energy thing, but it's part of decarb, because the less energy we use, the better off we're going to be. Is leaning into this space. Well, what does the future energy market look like? How do we facilitate the sort of low-cost, sustainable energy without lots of things sort of coming in on the side of it? So it's market design, I think, is really important. It goes to the circular economy and to the things that Amy's talking
Let
about.
me push the point a little further. Thomas Edison didn't sell electricity, he sold light. He would charge you a cent to run a lamp for an hour. And that's because he knew as an inventor people would come up with more efficient lamps, and when that happened, his cost of producing light would go down, so his profits would go up. But in 1892, New York Edison Company overruled him because motors were coming in for various purposes, and they said, look, let's not worry about what the customers do with it. We'll sell them the commodity and charge them by the kilowatt hour. The problem then is that as people use the electrons more efficiently, the provider doesn't so much lose cost as it loses revenue. It's a completely upside-down revenue model. And the hydrocarbon industries have made the same mistake of selling molecules when what you want is the service like comfort and mobility. 100%. So I think in order to get the revenue model right way up again and align the interests of providers and customers, we're going to have to sell or lease services rather than the commodity. And I don't hear enough of that discussion yet, but I hope it will get started quickly. So when we think about markets, what is it we're marketing?
I mean, that's exactly right. I mean, our members aren't energy day traders. They buy energy for its utility. because their business is running trains or making steel or making glass. The fact that energy is an important input to that, they don't buy energy, they buy the utility of the product.
We have a question at the back. Thank you, Nat. And again, if everyone can just introduce themselves and their organisation.
Yep, Murray Hogarth for the Fifth Estate. I've got to make 2 points to set this up. So one is I've spent several weeks now really looking into the nuclear push, and there's no question that part of it is people who just want to prolong coal, but there's another part of people who essentially do not believe that renewables can do this job, the energy transition job. And it's kind of like climate denial is moving to renewables denial. Second thing, Tony Wood from the Grattan Institute, writing in The Australian off the back of their report, is, saying we're off track on the energy transition and it, needs work and needs a reset. So my question to the panel is, do you believe we can do this? Can we deliver this energy transition?
I'm not sure that's exactly what Tony's saying. I think that, in that report, what he's saying is that we're in this world of muddling through for the next 6 or 7 years.
In this article in The Australian, I think he says that a bit more clearly, that it is off, it's off track.
Yeah, okay. But you want to jump in?
Yes, we can do it, and we should do it, and we have to do it. Whether we get to 82% by 2030, for me, starts to become irrelevant because the trajectory is there, right? Now, whether we get to 100% or not, who knows? I mean, I think from our perspective at the EUAA, we think gas is going to play an important role, a small but really vital role. But as technology evolves, then clearly we can maybe even go beyond that. But it's certainly... Jeff Dimry from Alinta made a really good speech gave a really good speech, at the press club not that long ago. He said, yes, it's going to cost, and yes, we need to get there, and of course we're going to get there. And the counterfactual is we're going to have to replace all this stuff anyway, right? Coal-fired power stations don't last forever. Nuclear power stations, not that I advocate for that, don't last forever. So we're going to have to do this anyway. And all we're doing is choosing the least cost path to get there, particularly when you consider the emissions aspect of where the world's heading. So it looks, and this is the problem I think a lot of governments face and we're sort of some of our members facing too, it looks like it's really expensive because we're building the plane while we're flying it for a start, which is always going to be a bit messy. But it looks like it's expensive. And it's difficult for mums and dads, though, around the kitchen table to understand counterfactuals because they're not economic degrees, don't have economic degrees. And it's a problem with around narrative. This is where we're really big on narrative, because you say to people, okay, my plan will deliver an outcome that is the cheapest of all the alternatives, or the least cost of all the alternatives. And people say, or least cost against the counterfactual. And people will say, well, what did you hear them say? They said my power's going to be cheap. I said, no, they didn't say your power's going to be cheap. They said it's going to be the least cost against all the alternatives. But they don't understand that concept. So we've got to change the narrative to get people on board. And what I'm really concerned about with the transition, if you like, is that you see the SEC Newgate Mood of the Nation polling. Mums and dads change politics and change politicians. And mums and dads now are concerned about how they feed their kids and how they pay their energy bill. And that softness is a real problem, because the people in this room, we're saying, no, we're just... And large energy users are going, we're going down this path. But what we don't want is for politicians to go soft on it, or politicians, to sort of be constantly changing track. So I think we can get there. I agree with Tony's points, though, that it has been a little bit of a mess because you've got federal and state jurisdictions crossing over each other. I don't want to get into the terrible details because they are terrible, but I think what the federal government's trying to do through the capacity investment scheme is lift the states up to get more better coordination. That includes orderly exit of coal. What's missing, though, for people in this room is what's the energy efficiency aspect of this? So do we really need to have a NEM in 2050 that it's 300 gigawatts capacity? It'd be fantastic if we only needed 250 gigawatts of capacity.
Yeah, can I build on that?
Yeah?
Yeah, sorry, Amory. I just wanted to say that, this is a classic version of just a very supply-side focused solution.
Exactly.
Missing partly the energy efficiency, but the demand response, the flexibility that sits within the distribution networks.
Yep.
That is part of that system. So some of the stuff that we look to do and to support is to actually be able to do a better job at actually quantifying that to help end users get there. I think building on your points, Amory, around just some of the visualization aspects, making that easier for people to see and understand. And I've spent a lot of time in a previous lifetime in research actually writing some visualization software around atmospherics at that time, but really just to be able to visualize and show different end users at that time in government different impacts. And it's really vital to get that right as part of the narrative. But we need to keep saying the narrative on the energy efficiency, on the electrification parts, and just move away from that supply side focus all the time. And the nuclear one is a classic version of that. And I won't even get into the cost functions on that, unless Amory wants to.
In this room tomorrow morning, I'll be giving some evidence on that question that Murray asked. For example, showing how to run the isolated and rather hot and often humid state of Texas grid on 100% renewables with no bulk storage and excellent economics. There are, as you suggest, not only strong demand-side opportunities to stabilize the grid with negawatts and flexawatts, there are also 8 other classes of carbon-free grid stabilizing resources or grid balancing resources on different timescales, of which the dearest currently are big batteries. It's therefore especially impressive that South Australia is 3/4 renewably powered at this point, and within a few years 100%. An outstanding example. The big batteries are producing the ancillary services more cheaply and precisely than we could ever do with rotating machines. It's a wonderful lab for the world. But there are other places as well, like, say, Denmark with no hydropower, or Scotland with some, Portugal, Spain, that are getting half, 3/4 or more for Scotland, 99% or so of their electricity from renewables right now, and often with better reliability and without adding bulk storage. Denmark and Germany have 5 times the reliable power supply of the United States, using a standard cited metric. So it is actually not the case that we are short of ways to run entirely on renewables, although the last few percent we don't need to argue much about. If you're uncertain about those, by the time we get there, we'll have options coming out our ears. But as Ken Caldera says, uncertainties about the end game should not inhibit our opening moves. And the SA example, I think, is a very nice case for whatever exists as possible.
Can I just add, just picking up on particularly Bill's point, customer empowerment is going to be so crucial in this. Empowerment and orchestration. I mean, when you think possibly half of Australia's energy in the future will come from someone's roof, or more likely 8 million little power stations dotted around the NEM. So that's a huge risk on one part of not having that orchestrated, but there's huge opportunity there in making around load shifting and getting the right tariffs in place. It's about customer empowerment. I mean, there's going to be every electric vehicle can potentially be a 2-way battery if we get that right. So we can actually reduce the spend on the big stuff. We spoke about this at our national conference 2 weeks ago, a bit late for a plug, but anyway, about the big stuff versus the little stuff. Yeah. And quite frankly, the little stuff's going to play a potentially far more important role than the big stuff if we get it right.
And it learns much faster, it has far higher capital velocity, and now it's getting lower capital intensity as well.
Yeah. And if you start building houses from scratch with this stuff incorporated, then you don't have to worry about other integration costs.
A shameless plug for our own joint work with ARENA, where now with SAPN looking at South Australia and looking at those orchestration in a large-scale electrification trial, really to build on that and to build the innovation and to build that sort of lessons and look at what we can do.
And it's not too late to plug my conference, because tomorrow morning, Amory Lovins will be opining on these topics. We've got the opening keynote with Audrey Zebulon, formerly AEMO. I think it's called Electrification Nation, which is kind of like how we kind of gather up all these Lego bricks and kind of put them together in a way that makes sense across the supply and the demand side. And if you stick around for 2 days, we'll get to ask Tony in the closing session of the conference exactly what he meant with his report. But in that report that Grattan released a week or two ago, there's a lot of stuff in that report, but one of the things that is really interesting is the way that he expands the conversation around social licence, which is what you're all saying. Because yes, there's a big debate about social licence in the regions, around transmission lines and large-scale renewables. We've got a massive social licence issue in the suburbs, and that's something that we need to think carefully about and building that narrative. And I know for a fact there are plenty of energy ministers around the country whom that's keeping them up at night, because we've got to keep voting for politicians that are willing to pull the lever for this transition. This is probably your last chance to pose a question or reflect. We've got a question in the middle here and one here, and then I think we're probably almost done. Well, we'll see how we go.
Good afternoon, Michael Snow, energy consultant. What you said, Amory, about as a service, that's been on my mind for a while. Everything's as a service these days. Why can't energy be as a service? Not electricity, gas, all forms of energy. And I think we've tried it here a couple of times at different scales, and we've really failed. And I think the reason we've failed is a lot to do with risk apportionment and how we sort of best meter that out between, who has control of the risk and who reasonably owns the consequence when it occurs. So my question would be, who would be, do you think, the best user group to, lead if we were to go down that path? And are there any global models that we can refer to that have been successful in the as a service, as you put it?
The best known would be the chauffagistes in France, metropolitan France, who provide most of the building heating as a service. They undertake on a competitive basis, many firms competing, to keep this many square meters within this temperature range during these hours at this price. How they do it is their business. So they'll probably start off by tuning up your furnace and buying cheaper fuel, but then they can even go all the way to a deep retrofit and passive. What they contract to provide is the thermal comfort. And we've seen some examples emerge in other countries of a froidagiste with refrigeration or space cooling, an illuminagiste providing lighting services and so on. And of course, if you're a building manager, you probably don't want to contract for a half dozen different services, so they will start getting bundled. But I think for buildings, it's more obvious. I have heard of some rotagistes, so to speak, providing industrial torque, kind of like power by the hour from jet engines, the Rolls-Royce model that's taken over the aviation business, but coming into industry. And normally an industrialist will not want somebody messing with the process, but perhaps they'd be willing to contract out the torque. And a specialist firm may actually do very well with that. So I haven't, let's see, there is in my slide earlier today, there's an industrial high temperature heat pump company, I think 180 C or thereabouts, that's provided as a service for conversion from a gas boiler or gas furnace. And we're starting to see this emerge, but I would think there'd be plenty of good entrepreneurs in the room to figure out what's the right place.
Great. We have one more question over here. Thank you, Amelia.
Hi, I'm Natalie from ABB. My question is for Amory. We talked a lot about technology today, a whole lot. And earlier, Amory, in your presentation, you talked about the efficiency ratings for motors. You mentioned that huge statistic that 50% around about of the world's energy comes from the consumption of electric motors used in industrial applications. So that's about 300 million motors in the world that are still inefficient today. But what I'm thinking about are the variable speed drives, or sometimes they're referred to as variable frequency drives. And we know that when pairing your drive with a motor, you can actually increase the energy efficiency further by up to 30%. But despite that, there's still about 23% of electric motors in the world that aren't using drives. So I'm wondering, do you know or do you have thoughts about why there is such a slow adoption, or is it kind of like putting the cart before the horse because there's so many inefficient motors still in the world, people aren't really thinking about pairing them with those variable speed drives?
Well, analyses like that of the International Energy Agency assume that you go for higher efficiency, typically asynchronous motors and variable speed drives. Those are the big two. We actually look at 35 things you do to motor systems, of which I think I mentioned 28 are free byproducts of the first 7 if you do things in the right order. And then you save twice as much energy at about a fifth the unit cost. So I have a much higher ambition than just increasing the market penetration of ASDs. They're a good technology for many applications, but they're a small part of the total story. And the new types of motors coming in, some new configurations, axial flux and so on, and especially my favorite, the switched reluctance family of motors, can do things we never thought we could do with motors. Remember also that you only retrofit the motor system after you've done the reduced load. So if you have a passive building that doesn't need you to circulate chilled water or run a chiller because the building's designed right, you just got rid of a bunch of motors. If it's not quite that good, at least you made them a lot smaller. And when you do the pump and fan improvements by fat, short, straight pipes and ducts, that's a factor, typically 5 or 10 reduction in motor size. That's when you get to do a retrofit with a very efficient but much smaller motor system, and the total capex goes down. So I want to jump ahead to that sort of whole system, deep retrofit, just as we do for buildings or hot water systems or anything else.
All right. I'm going to try something because I have a bunch of people to thank, but I want a final thought from all of you. But I want to give you time to think about what you would leave us with coming out of today, coming out of the conversation, and some of the next steps, the kind of the priority for action coming out of today's summit. Given that we're all invested, I haven't heard a dissenting voice over the course of the day that says, "Well, this is not important." I guess the question is how we accelerate. So you think about that, and I'm going to take a moment to thank our partners, New South Wales Government and the Australian Department of Climate Change, Energy, Environment and Water. I can't overstate how critical the partnership between our organisation and many of the other not-for-profits in the room and the New South Wales Government and the Australian Government is in this agenda. There's no way that we can accelerate momentum without that very close partnership. Obviously, Race for 2030, Bill, Marg, John and Beth Brenoro, who tragically is not here, she's unwell, but sends her apologies, and just a huge amount of work between the EEC team and the race team in pulling this together. Our gold partners, Schneider Electric, and networking partner AGL, the EEC members coming to the table and backing in all events like this is so deeply appreciated. It's how it happens. We've had incredible speakers over the course of today, and thanks to everyone, each and every one of you. The gameness with which this audience has engaged with the cheeky questions that we've posed to you, and I think that we can all look forward to a fantastic report from Marg, sort of collating all of that information. We're going to share that with you for feedback, and ultimately that's a resource that is going to be shared publicly and amongst the partners to think about those next steps. The exhibitors upstairs and downstairs, can I just say, the food here is absolutely amazing. Like, I want to really give a big shout out to the caterers. It's really remarkable. This is not standard conference fare, I think you'll all agree. Also, all of the staff here at the Roundhouse, and especially the Energy Efficiency Council team. I really want a big round of applause for everybody from the Energy Efficiency Council that's pulled this thing together. This is amazing. I get up here and talk shit for several hours over the course of the day, but everybody's behind the scenes doing the hard work. So can I please get a round of applause for my team? So now I've given you time to think. Andrew, what is your final thought? What are you going to leave us with?
Yeah, probably two things, and it's narrative.
Yep.
We've got to have a change of narrative and an honest conversation so that we understand what is the most likely future state, not a future fantasy state. Because we need to know and have that honest conversation and narrative around where we're heading, and I can't see that in very many places. Because unless you've got a clear picture of where you're heading, how the hell are you going to get there? Okay. The second thing I'd leave you with is, as I said before, we're a small country, we're at the end of the world, we tend to be takers of capital and technology. How do we turn that around? What is, as Australia as a company, what's our unique selling proposition?
Yep.
And I'm not sure we fully understand what our unique selling proposition is. And once we do, and really lean into that, I think we can get a faster decarbonisation of industrial energy users than we currently contemplate.
Helen?
Tambourines. They're
Love it.
better than recorders.
They are. I've got a 7-year-old. They're definitely better than
Government's
recorders.
usually pretty good at kind of working out what a carrot is, billions of dollars, what a stick is, or let's put more
We don't like
regulation,
sticks.
you know. But the tambourine, I'm going to back in my New South Wales colleague who was on the panel before. Governments really need to lean in to sharing best practice, to sharing how to do this.
Yep.
So that's what I'm left with, and pondering culture.
Yep. And we had a friend from Asahi making that same point in the last session, is just how important it is to celebrate excellence and share those stories. Lisa?
Yeah. Thinking from the private sector, I would say urgency. We need to make sure that people understand urgency. I was at Impact X 2 weeks ago. Did a lot of agriculture conversations. There's only 6 harvests till 2030, which doesn't seem like a lot. Urgency. The second that I would leave you with is bringing us full circle to Auntie Maxine this morning. The people in this room should be the role models, and we should be deploying the technology that exists today ASAP.
Okay.
Yeah, I'm going to go with the carrot as a stick. So, I think just embrace innovation, quite frankly. I think we're too worried about risk. We don't see the reward that comes from innovation, and we'll take simple sort of incremental steps because of that. And I'd like to see that, I guess, the curiosity factor that Amory talked to, but really building on that and accepting that we can be innovative. Building on Andrew's point, it's actually probably one of the things that Australia has going for it. Its isolation actually does lead it to be a little bit unique and innovative in a number of spheres, and we should really embrace that.
Great. Amory, bring us home.
I agree with all of those comments, and I want to add one perhaps heretical idea. We tend to get caught up in payback times and IRRs and the economics, microeconomics of energy savings. We may be missing a big bet here. In the building sphere, there are side benefits of energy efficiency that are worth typically 1 and often 2 orders of magnitude more than the energy savings, like 6 to 16% higher labor productivity in an office where you can see what you're doing and hear yourself think and feel thermally comfortable. This extends in great detail to all the kinds of buildings. 2,500 peer-reviewed papers from Roger Ulrich's collection on better clinical outcomes in efficient hospitals and other places of healing. And so on. Well, it turns out that these valuable side benefits are often, in my experience, enough to make the sale without ever mentioning the economic savings. So in real estate, there's this fat book by Scott Moldavan called, I think, Value Beyond Energy Cost Savings, something like that, that says if your building has this or that efficient green attribute, it will add this many basis points to your cap rate, and here's the evidence. It turns out the same thing is true in many manufacturing industries. And in industry, as in buildings, we can often make the case and make the sale without ever mentioning the economic benefits that accrue directly. And then on our way out, we'll mention, oh, by the way, you'll get an 8-month payback, and the client says, what? You mean I'm actually going to make money on this too? I want it anyway for all these other reasons. So don't think of your value proposition too narrowly, and you may find it gets easier than you thought.
That's a great note to end on. I want to thank our panel. I particularly want to thank Amory. This is a new event. As I said, we're breaking out the conversation on industrial because we think it's so important that we have this laser-like focus, because there's so much that we unpack in this space. So I acknowledge we've just scraped the surface today, but it's a conversation that we want to keep going and returning to. But to have someone of your calibre, Amory, joining us to just get the ball rolling, to build that momentum has been incredibly helpful. And I think, it sets the tone in terms of the ambition that we should be striving for, and the benefits of ambition for actually making the whole task easier. If we try and do this incremental little bits and pieces, I can guarantee we won't get there. If we actually set the ambition at the right level, not only will it be cheaper, it'll be easier, and we actually have half a chance of getting to where we need to be. So a round of applause for our panel and Professor Amory Lovins.